Hi, everyone, and thanks for joining us here. And we're going to be talking about speeding time to insights with a modern ELT approach, specifically how to do this with a modern data stack using a few key tools of Fivetran, Databricks' new SQL Analytics service, and DBT. Uh, I am Sean Spidiacci, and I'm the Senior Product Marketer here at Fivetran. And I'm joined by Amy Diora from Fishtown Analytics, the head of alliances there. And she will be running us through the last half of the presentation and into the demo of how these tools can interact with each other. So really, let's start with the challenges for data analysts. If there's really been always a focus on infrastructure and that compute and storage around big data, but ultimately there's been a few key challenges that we're always trying to solve for. And that's how do we build and scale our ETL, our pipelines? And in order to do that, we've always taken this approach of extract, transform, and then load. And how do we control our storage costs? Because ultimately we might be dumping them into systems that are inherently expensive, and how do we control and optimize for those costs? Then how do we optimize for performance? We need to structure our databases in such a way that we're going to get that higher performance, that our queries are going to run efficiently, and then we're not redlining our box or increasing the cost of compute on our usage-based, new usage-based systems. But ultimately, how did we get here? Where did we start? This all started with a single node database, these on-premise systems that had this inherent constraint on compute and storage. And we had to pay for them in perpetual licensing manner. We couldn't just say, let's auto scale up and down as we do today. And because of that, we had to limit our pipelines in that ETL manner that I mentioned before. And I had to extract only the subset of data, transform that subset of data, and load it into data marts that were accessible by only specific users of those systems. And I had to optimize the structure of that database so that way the queries ran performantly. We eventually got to scalable databases, and we had this division of storage and compute, but they generally were on-premise. And we had these subscription licensings that limited how much system we had at any point in time. Maybe it was complex to manage at any point in time, and we didn't really get all of the pipelines that all the pipelines for the data that we needed, because we still had that problem of my storage compute are inherently tied together. I can't independently scale them. Now, we have we're living in this era of modern cloud destinations where we not only have this division of storage compute, but we have this usage-based licensing where I can auto scale up and down depending on what I need from a storage perspective or a compute perspective. So now we can have these agile data pipelines that are just pumping data into these systems and not focusing on how should my data be look before I load it in. And that's really what's delivered us a ELT approach versus an ETL approach. And we're able to take advantage of this cloud storage system of these data lakes or warehouses. And we're able to automate the entire extraction process into moving the raw data into these destinations, and move the transformation into the data warehouse and take advantage of that scalable compute. So that way we have these clean, usable data sets that can be used. But ultimately, while we can automate the extract and load functionality, we cannot automate that transformation functionality. And it's different from every company, and we need to figure out a way to solve for both. Now, before we get into how we solve for that, what we're learning from ELT and ETL is that we're no longer having to wait for IT teams to add features or new tables, or maybe a pipeline is broken, submitting all those ServiceNow tickets in order to get new data sources when we do need to add them, and then go through a weeks-long process to figure out if that's the exact data we need in the format that we need it. And then we also have a way to give more visibility to analysts and data engineers both into the entire pipeline, and not just that final data mart. where you're only accessing the end data. I could actually see how my data is transformed if I'm using, let's say, SQL as my pipeline. Your data analysts have an easier time reading the underlying code if it's held in a central repository. Now, what does this modern data stack look like, especially when we're talking about switching up the T to the end of ETL and making this ELT? So with Fivetran, we're taking all of your disparate systems of databases, applications, and files, and we're putting them into these normalized schemas for dbt to then take advantage of and do all of the transformations inside of these powerful destination systems, these lakehouse systems, like Delta Lake, and taking advantage of the compute there, modeling that data, and then using it for business intelligence and data science. Now, for the E and the L, especially from a Fivetran perspective, we're automating that entire piece. We have these pre-built connectors where we have applications, databases, events, files, and function connectors where we normalize the data that comes through, whether we're mapping the schema or actually creating the entire schema from start to finish, and then delivering it to this destination in an analysis-ready format for you to immediately transform using dbt. And in that process, we're doing a couple things. We're doing automatic data updates. So if there is any inserts required or updates to a row, we'll automatically do those DML statements for you. If we need to create that schema, maybe add a new row, change it, we have those DDL statements that we're automatically migrating any schema changes that come along. And in case you're wondering how we're built and why we're able to do this in an efficient way, especially for all of our customers, we built this in an idempotent manner. We're able to recover from failure at any point in time. We know our point of last success, and we restart from that point if we do run into an error at any point in time. And then we retry, and then once we have success, we have a new point of success. And that's because we're doing this in a change data capture method whenever possible. And that enables this micro batch architecture that we're only taking the changes that have happened in the source system and delivering it to the destination. And if we don't have access to that pre-built connector, you can then extend Fivetran by building out and utilizing those cloud functions of AWS, Amazon, Microsoft, and Google, and then building into a new connector for Fivetran to then load into these destinations. Now that's the E and the L. From here, I'm going to let Amy take over and talk about the T, the transformations, and that's where dbt will take over and really start munging that data that you're going to start taking advantage of. And with that, Amy, please take it away.
Hi guys. As Sean said, for the T in this ELT workflow, we often see dbt used for that. So dbt is an open source data transformation tool that lets anyone comfortable with SQL author their own data pipelines. So what does that mean? Primarily, dbt is a rich programming environment that you can wrap around SQL. So using dbt, you can use things like control structures, like if-then statements or loops. You can call local variables or macros. So all of those things that you're used to using, if you're used to authoring pipelines in, say, Python or R, you can use all of those things in dbt while keeping all of your fundamental data transformation logic in SQL. One of the most kind of fundamental things about dbt is that dbt can infer a data lineage graph or a DAG as you code. So dbt has the ability to have something called a reference function. In a reference function, you can actually refer from one part of your data pipeline to another part of that data pipeline. And that creates, kind of in data engineering speak, an edge in your DAG, meaning that it enforces that reference every time you run your dbt project. So that means that, for example, you don't have to tell dbt in what order to run different parts of your data pipeline. dbt can infer that and knows that for you. DBT also includes the ability to a set of tools that help you kind of automate testing for your data pipeline. So both being able to figure out whether your data pipeline is something's not going to run and it's going to break, and then also being able to have people run tests so they understand changes in the underlying data that are ingested into Delta Lake. And then also there's a set of capabilities for CI/CD ready best practices. So for example, the ability to version control your code using any Git-based service, and then also the ability to set up different environments. So for example, often in DBT, a user will have their own sandbox environment where they can kind of run their code when they're in development mode. And then there might be kind of a dev test environment or production environments as well. And DBT has the ability to kind of support all of that. And also DBT auto generates documentation as you code. So thinking about kind of how all these pieces now work together. So setting up kind of this type of ELT pipeline on the modern data stack. You start with Fivetran. So let's say you had a set of kind of transactional databases, an e-commerce data source, and a CRM. You could set up in Fivetran a connector to each of those data sources. Fivetran normalizes your data, does deduplication and cleaning, and then maps it into a consistent schema onto Delta Lake. And then DBT can connect to that schema on Delta Lake and then run a set of data transformations that then convert that data into whatever data format you want to communicate with the rest of your data stack. So that might be a data series of data marts or data hubs or anything that's ready for your semantic layer to put into a business intelligence dashboard or even to feed a data science workflow. So now we're going to show an example of how you can set up a data workflow using this ELT structure that Sean and I talked about. So we're going to use Fivetran and DBT on Delta Lake and the new SQL Analytics workspace. And this isn't meant by any means to be kind of like a full tutorial on any of these products. It's just meant to give you an idea of how these pieces work together and kind of how you can really get started really quickly. And one of the things that we're going to use to get started really quickly on DBT is a Fivetran DBT package. So DBT packages are just open source projects that you can download that do kind of a set of, that have a set of utility functions associated with them. So Fivetran is setting up a set of packages that create a set of data models that do kind of common transformations and calculate common metrics on top of the data in the schema in which Fivetran ingests it. So this is like a really easy way to kind of get started really quickly in data modeling. And Fivetran has a group of packages right now, and they're continuing to add about a package a week so that they'll have pretty good coverage in terms of having a set of packages that work with all of the different types of connectors that Fivetran has. And then finally, we're going to create a dashboard through the Databricks SQL Analytics workspace using Redash. So to do this demo, we're going to use some GitHub data. So at Fishtown, our mission is supporting the open source DBT project. So as part of that, we often look at things like the number of pull requests and issues and things like that coming in. And that's how we measure kind of engagement in our open source project. And then also the workload of our product and engineering team. So I'm going to take those data, and let's say I wanted to put together that GitHub data and take that raw data and make a set of dashboards that can have a set of metrics that can inform my team going forward. So now we're going to show exactly how that works using Fivetran, DBT, and Delta Lake. So my first step is going to be to get my GitHub data into Delta Lake. So to do that, I need to set up a GitHub connector in Fivetran. So I can do this through a really easy visual interface in Fivetran. And I have to say I'd actually never done this step kind of before this demo, and I found it really easy to do. So basically I go through and I can select whatever schemas that I want to replicate and the tables that I need. Then I can set this up to replicate at whatever sync frequency I'd like. So it's set up to run every 6 hours. And then I can actually see what happens as my data are loading. So for example, I can see on the schedule, these little green guys show me that my data are replicating completely. And then I had an error here. So this red bar means that the sync failed for some reason. And Fivetran is smart enough to know when it does fail And the workflow is idempotent, meaning that basically when it does fail, it's smart enough to pick up where it left off, so you don't end up with kind of a half-baked set of junk in your destination. So it can easily kind of repair when that pipeline breaks. And we see here that it takes about 13 minutes or so on average to complete that entire sync. And so what we have once that's done is we have a set of tables that are replicated into Delta Lake. So here I can see this GitHub schema set up with all of these tables here. And so what this provides for me after my EL step is done is a very complete but a very raw set of tables that then I need to transform. I want to do that through DBT. Fivetran has put together a set of DBT packages that can help me do that more quickly. So I'm going to go to the DBT hub and I'm going to look for a DBT package that would help me. So what are DBT packages? These are open source utilities that help you do kind of really common steps in your data modeling. So there's two types of packages. One is just utilities and things that help you do common things in projects like, work with dates and times and things like that. And then there are a set of packages that actually help you model data. So they're built to put together a set of pre-made data models on type of data that come into your destination in a particular schema. So Fivetran has a set of packages that they're adding to all the time that I can kind of use to jumpstart this process. So I'm going to go ahead here to the GitHub package that I see, and it can give me some quick installation instructions. So I need to call this package in a file called packages.yaml in my project, and I need to do a few other things in a configuration file as well. And then it gives me some documentation. Now that I have that step, I'm going to go ahead to DBT and go ahead and get started modeling. So this next part can be done in open source DBT or in DBT Cloud. If you're working in DBT Cloud, you can work either in the command line or in the IDE, the Integrated Development Environment. So I'm going to develop in DBT Cloud, and I'm going to develop here in the IDE. So the first thing that you might say if you're used to using DBT Cloud is, hey, Amy, you're using Databricks, so you're not going to be able to connect to your database the same way. And instantly that was correct. But recently we developed support for Spark in DBT Cloud, and also we are in beta for a new connector to the Databricks SQL Analytics service as well. So we'll have those two options for folks working on Databricks. So first off, I'll just give you a quick tour of the IDE or Integrated Development Environment. Over here, we have this section that has all of my files on my DBT project, and these are version controlled in GitHub, so I can commit my changes or pull down a new branch over here, even submit a pull request. Over here in this section, I have my development environment for my data models, so I can interactively run SQL, see what my models are going to produce, and do some development work. And then here I have my section where I can actually run my DBT commands. So the first thing that I want to do is include my packages in this project. So I'm going to go to packages.yaml, and I've already typed this in. So I call this Spark Utilities package that's going to be useful for me because I'm working on Spark, and this GitHub package here. And note I could call as many packages as I want to in this section. So the next piece that I need to do is I need to run a command called dbt deps. That stands for dbt dependencies. So what does dbt deps do? So dbt deps basically pulls down everything that I need from my packages that I'm trying to install so that I can run my project. So I've already run this here, so you don't have to watch me type it. So after I have everything that I need for my project, I can type dbt run. So I can run my dbt project that includes all of my packages. So when I type dbt run, what happens? So dbt run basically compiles all of my data models into pure SQL. It then wraps those data models in all the DDL and DML and everything that I need to communicate with my database of choice, whether that's in a data warehouse or in Delta Lake, and then it runs that SQL there as pure SQL. So while we wait for this to run, let's go ahead and see exactly what this DBT project is doing. And let's do that by looking at the documentation that we have. So here we have this lineage graph that represents what's happening in the project. So we can see in green here, we have our source tables. These are the sources that were replicated into our database using Fivetran. And then each of the blue rectangles here represents a data model that's built by DBT and was built through the Fivetran package that we installed. So one of the things about DBT is we have a wide range of materialization strategies. So for example, in this project here, I have these early staging models that are just kind of a way station onto the tables here that provide my metrics. So these are materialized as ephemeral models, meaning I'm not going to see them sitting in my data lake. They're just basically persistent queries that then I can model on top of. So these models in my data lake are materialized as tables that I would want to share with the rest of my analytics team. So I have a set of daily metrics, and then on top of that, I have a set of monthly, weekly, and quarterly metrics. Actually, at this screen, I can access documentation as well at the model level. So for example, I can look at what's great about the packages that Fivetran has developed is they actually include these descriptions both at the table level or the model level and at the column level as well, so that your data models are kind of automatically documented when you use a package. And I can actually see here my code. Here's my DBT source code, and here's what that looks like when it's compiled to SQL. And one of the things that we can really easily see here is the power of the reference function. So a reference function is a reference to a data model or to source data from a data model. And that reference is enforced every time you run your DBT project. And that reference creates an edge in your DAG and actually enforces that data lineage every time that you run your project. So now let's go back to DBT. We can see that our code has finished running and we have developed a set of tables now in Delta Lake. So we can go back to Delta Lake and see them here. So I have my GitHub schema, and I can also look and see that I have my personal schema called DBT Adiora. This is kind of my sandbox schema that I've asked DBT to set up as part of my testing environment. So now I have these tables all materialized here in Delta Lake. So now I'm going to go back to DBT. So one thing that we mentioned before in the talk about the ELT workflow is that while the EL part is very automatable, the T part of our workflow, the transformation step, is just fundamentally not as automatable. Every single company is going to have a really distinct set of measures and metrics in a way that they want to transform their data. And that's going to be hard for any kind of automated process to anticipate. So the package is a really good way to get started, to get a quick insight and show a really quick win. But you're almost always going to want to go beyond a package and build on your own data models. So you can do that either by branching off of or building on top of the models in the package. And most commonly, users end up creating their own custom models, often leveraging the code that's in the package to give them a head start. So let's get a really quick example of how we can actually build onto the package and add our own new data models on top of the ones that we've made here. So going back to our documentation, we can see that we have this set of daily metrics here that then feed this set of monthly, quarterly, and weekly metrics. Now let's say that we wanted to add another data model that aggregated these metrics annually. So let's go ahead and add a model to our project in DBT Cloud to do that. So the first thing that we want to do is add a data model. So I can put this in my models folder. I'm just going to add a new file here. So I'm going to call it GitHub annual metrics.sql. And by giving it that SQL extension, I've told DBT that that's a data model. So I'm going to go here, and one thing that I've already done is I have these quarterly metrics that I'm calculating, and these are the same metrics that I want to aggregate annually. So I'm going to use a lot of this code that I already have so that I can do that. So I'm going to go ahead and cut this code or copy this code, and I'm going to paste it now into my new .sql data model. So the only thing that I need to change here is I'm aggregating this by quarter. So I want to go ahead and just add some code that does that by year. Okay, so I've done that. So I'm going to go ahead and run my SQL here and see what I get. So what's great about this is after I make this new data model, every time that I run my project by typing dbt run, this model is going to compile with the rest of my models. So I have this model that I can use on top of my package as well. So I see that I have this compiled, and I see in SQL, I have these results here. And I can actually also download this as a CSV if I would like to do that. So now that I've got all my data transformed into a usable state and it's sitting on Delta Lake, anyone in my business can access these data and these models so that they can develop visualizations and dashboards and metrics and things like this. So here on the new Databricks SQL Analytics workspace, I can see these quarterly GitHub metrics. These are what I've developed from my package. I can add a visualization here in Redash through a really easy dashboard. So I can give this a name. Let's say I want to do pull requests by quarter. I can make a bar chart, and then I can just select X and Y axes here. So this is a really easy way that I can do visualizations. And I've already gone ahead and created a dashboard here that has some of the data that I got from my GitHub models. So here I just have pull requests open and merged by quarter. I have some more detailed data from the last month. And then here just number of pull requests merged over time since we started in 2016. And then here I just put together kind of a simple word cloud that represents a lot of the text that we see in our issues and pull requests. So now that I have this end-to-end workflow, I want to automate it. So I've already automated the Fivetran ingestion step, so that's running on a schedule. And once I'm happy with my DBT project, I can also schedule that to run as well. So I'm going to go back to DBT Cloud and do that. So I can do that here by going to jobs. So I can set up my new job, I can give it a name here, and I can use any DBT command that I need to run, and I can set that on a schedule. So I can set it to run, for example, every Tuesday at 5 a.m. or on any schedule, which I can write in cron. And one thing about the workflow, both in Fivetran and in DBT, is that the workflows are both idempotent, basically meaning that every time you run it, you get the same thing. Then in the Databricks SQL Analytics workspace, you can also set your dashboards to auto update. So once you set this up once, you're good to go. So as you can see, we were able to put together this workflow really, really quickly from base GitHub data using Fivetran and DBT packages, all on Delta Lake, to be able to put together a dashboard really, really quickly. And all told, it actually really did take less than an hour, even kind of given that we were setting up a lot of these tools for the first time. So hopefully this gives you an idea of what the ELT workflow looks like and an idea of how you can get started really quickly if you want to try it out. Thanks so much for your time, and we look forward to your questions and your feedback. Thanks so much.